All right, here's my video guide for lesson 5.3.3, and we're going to focus on the law of cosines. And so the previous lesson, well, 2 lessons ago actually, we realized we had some triangles that we couldn't solve. And 2 lessons ago, we realized that only really right triangles we had tools for. And so in the last lesson, 5.3.2, we found out this law of sines. And the law of sines worked when you had 2 angles and a missing side that was across from one of those and then a variable across from the other angle. And you could use the law of sines to solve for that missing variable. Here, we're going to use the law of sines in a different situation, but still, again, a tool for a non-right triangle. So it comes in handy here. All right, the situation where the law of sines is going to come into play for us is these 2 that you see on the right, where you see an angle between 2 sides, one angle between 2 sides, or if you just have a triangle with 3 side lengths. Okay. By the end of this lesson, this is going to be the last tool we're going to have. So we're going to have all our trigonometry, sine, cosine, tangent. We're going to have our inverse trigonometry, inverse sine, inverse cosine, inverse tangent. We're going to have our 30, 60, 90 rule. We're going to have our 45, 45, 90 rule. We're going to have our Pythagorean triples. We're going to have the law of sines and the law of cosines. So there's a lot here in chapter 5. And just make sure that if you're uncomfortable with any of those topics I just listed, you reach out and get some help. Let's get into what the law of cosines is and how we can use it to solve for missing side lengths. So here is like my first slide, and it's just because I wanted to set this lesson up to show, okay, here's the formula, let's practice it. So a little different than the way I approach the law of sines, but I think it's because the law of cosines is a little more in depth. And so the law of cosines is written below. Okay, you can read what it says, but the law of cosines is specifically what we see here, and that is c squared equals a squared plus b squared minus 2 times a times b times the cosine of angle C. Okay, angle C is this angle right here, and then A, B, and C are the rest. The one to note is that this, what they call C squared or what they call C, is always going to be the side across from the angle that's given. Okay? And so let's see a problem like this. Let's use this equation. Let's plug it in, and I'll give you some tips on how to do it effectively, and you're going to need your calculator to do so. So I'm grabbing mine right now. Let's take a look at slide number 3. So here we want to use the law of cosines, which again, it's nice to even write it down, helps you remember it, is going to be c squared equals a squared plus b squared minus 2 times a times b times the cosine of angle C. Now I have this problem here to the right, which is labeled nice. They give you your angle C, which means the side across from it is your little c. And then you get to choose out of the other 2 sides which one you want to be A and which one you want to be B. I'm going to choose this to be my A. No, let's not do that. Let's choose this one to be my A because it's across from angle A. And let's choose this one to be my B because it's across from angle B. Makes more sense for what I'm saying. Then it's just a series of plugging in numbers and then doing our calculations correct on our calculator. So c squared, we have no value there, so it stays c squared. A squared, that's going to be 22 squared. B squared, that's going to be, so plus 20 squared, minus 2 times our A, which our A again is 22, times our B, which is 20, times the cosine of our angle C, and our angle C is 95. Okay? Now, what I do is I go piece by piece here. I don't do any addition or subtraction until the very end. Okay, so I'm doing, first of all, c squared stays c squared. Next thing I do is 22 squared. And I recommend you do it this way too until you're more comfortable with your calculator and calculating these out. So 22 squared, that gives me 484. Plus 20 squared, and 20 squared I know off the top of my head, that's 400. Let me check on my calculator just so I don't get it wrong. Yes, 400, okay. Minus 2 times 22 times 20. And I do this, all right, what I do is I take negative 2, I take this as a negative 2, and I multiply it by 22, so that's negative 44, and then I do negative 44 times 20. So negative, and that's what I'm going to put in my calculator, is negative 44 times 20, and that gives me minus 880 times cosine of 95. All right. The next thing I'm going to do is try to get rid of this cosine. So what I'm going to do is I'm going to take negative 880 times the cosine of 95. So c squared, oops, I want to use my math notes. C squared equals, we're still going to have this be 484 plus 400. Now I got negative 880 times the cosine of 95. And that gives me 76.697. So this is going to be a positive 76.697. And now I get to add the rest of this together. Again, calculator here is your friend. C squared. Adding together, I got 484 plus 400 plus 76.697. And I got an answer here of 960, so 960.697. Then I just need to square root both sides. And I would have my answer for C, which I'll do here. I get the square root of 697 gives me 30.995 if I round it. So my answer is 30.995 if I rounded it. Okay, those are my steps to completing a law of cosines problem. Just label your sides. What's your C? Again, your C is always going to be the side that's across from your angle. Choose your A and your B. Plug them in, and then work step by step. Again, I did the squaring, and then I did this multiplication, negative 2 times 22 times 20. That's where I got this negative 880 from. Then in my next step, I have it all written out, and I do my negative 880 times the cosine of 95, and I got a positive 76.697. That's why that switched to a plus there, because I took this whole thing, I took the negative 880 and multiplied it, so whatever I got as an answer, I could keep the sign of, which I got a positive, so I made it a plus there. I added it all together, and I got my value for C. Moving through the lesson here. Slide 4, we have another law of cosines problem. All right, again, use your law of cosines here or from slide 2 and try it on your own. So this one I'm not going to show. If you'd like to see an answer for this one, let me know, and I will share it with you to check your answer. Slide 5, it's going to open up a new problem. So that was 96. Both of those were 596. Here's 97. And what your goal is on this one, okay, is to figure out which tool should I use to solve for x. So it's a big problem for us, all right? You have 3 triangles in slide 5, slide 6, and slide 7. You have 3 triangles solving for x in each of them. Okay, you need to figure out what tool should I use and then use it to solve for x. Okay, I'm not going to give away which tool you need to use in this problem or any of them. All right, if you have questions on them, just reach out and ask. We should be confident in one like 5, 6, and now 7. Okay. Lastly, we have this problem here where we need to solve for this missing angle, and they're using an alpha. Okay. Now, what I'm going to do here is kind of unique and kind of new, so make sure you're following along with what I got going on here. Okay. What I have is, again, a law of sines or cosines. We can use law of cosines here to solve for this missing angle. And remember, our law of cosines is c squared, let's get it written down, equals a squared plus b squared minus 2ab times the cosine of angle C. All right. Well, in this problem, we have an A, we have a B, we have a C. The only thing we're missing is a cosine of C. We're missing the cosine of our angle. So what we're going to do is we're going to plug in everything, and we're going to eventually solve for this missing angle. So plugging in, 10 is going to be my C because it's across from my angle, and then 7 is going to be my A, and 8 is going to be my B, and I'm just choosing that to be A and B. Plugging in, I have then 10 squared equals A squared, which is going to be 7 squared, because that's what I chose to be my A, plus 8 squared, chose that to be my B, minus 2 times A is 7, times B, which is 8, and then times the cosine of C, angle C. Let's use capital. All right, I'm going to continue working this here until I can get, I'm going to try to get really cosine of the angle C by itself. So first I'm going to use all the squarings here. 100 squared, or 10 squared is 100, 7 squared is 49, 8 squared is 64. Negative 2 times 7 is negative 14. And negative 14 times 8 is going to give me negative 112. Again, times the cosine of angle C. Let's still try to work to get cosine by itself. So what I'm going to do, I'm going to subtract over 49. I'm going to subtract over 64. And so I got 100 minus 49 minus 64, and I have negative 13 over here. Negative 13 equals negative 12, negative 112. All right, negative 112 times the cosine of angle capital C. Now here, I'm going to divide both sides by, because this is attached through multiplication, so I'm going to divide both sides by negative 12. Okay, and what I get then is, and I'm going to leave it as a fraction. I'm not going to put it as a decimal quite yet. All right, so what I get is negative 13 divided by negative 112. I want that negative to be on top. There we go. Equals, again, the cosine of angle C. Now, this is nice, all right? I have the cosine set equal to this value here. But what I need to do, and this is weird, this is something that's new, and this is the part that I really want you to pay attention to, all right, is what I'm going to do here to get the angle C by itself. So what cancels, just like we talked about when we talked about inverse operations, when we first did inverse sine, inverse cosine, inverse tangent, okay? Addition and subtraction, they're inverses. Multiplication, division, they're inverses. Squaring and square rooting, they're inverses. So what I'm going to do to get rid of the cosine is use its inverse operation, and the inverse operation to cosine is cosine inverse. So what I'm going to do to get rid of the cosine is take the cosine inverse of both sides. So I'm going to take the cosine inverse of the side here, and I'm going to take the cosine inverse of this side over here. Okay? What happens on the right side here is the cosine inverse and the cosine cancel each other out, so I'm just left with angle C, which is what we want. And then I have the cosine inverse of negative 13. So the cosine, oops, got to use my inverse button, cosine inverse of negative 13 divided by negative 112. And I have 83.33. 83.33, and that would be how many degrees is your angle C right there. So we found out what our alpha was. It's our angle C. All right, we'll see a couple more problems like this in probably our review going into the test. I'm not sure if it's something that we're going to assess on, but I want us to know how we can use this to solve for a situation like this. If you have any questions, if you want to see another problem like this, always reach out and ask.